Imagine standing in front of a massive telescope, peering into the depths of space, when you notice something truly shocking. The cosmic beast you've been observing, a supermassive black hole, has suddenly shifted direction and is now aiming straight toward Earth. Your heart races as you think about the unimaginable power of this entity, capable of devouring stars, planets, and anything that gets too close. Could this be the end of life as we know it? It sounds like the plot of an intense science fiction movie, doesn't it? But this is no fictional tale. This is the kind of discovery that has sent ripples through the scientific community, and it's a reminder of just how unpredictable and awe-inspiring the universe can be. Recently, NASA unveiled a discovery that has left scientists both fascinated and concerned. A black hole, which was previously considered stationary, has undergone a dramatic shift in direction. This was no ordinary black hole, it's a supermassive one, located at the center of a distant galaxy known as PBCJ 2339. This black hole, which had been relatively stable for billions of years, suddenly rotated 90 degrees, sending its massive jets of energy toward Earth. For a brief moment, the terrifying thought of this monster turning its attention toward us seemed all too real. Could it be heading straight for our home, the Earth? But before you start panicking, let's dive into the details and explore exactly what this discovery means, what it reveals about the behavior of black holes, and how likely this scenario is to pose a threat to us. The good news is that this black hole is located in a galaxy that is not moving toward us but is instead moving away. The distance between Earth and PBCJ 2339 is vast, far enough that even if the black hole's jets are now aimed toward us, they won't have any immediate effect on our planet. These cosmic jets, which are streams of highly energetic particles emitted by black holes, are incredible to observe. They can reach speeds close to the speed of light and release tremendous amounts of energy, making them one of the most powerful phenomena in the universe. But before we get carried away with the idea of black holes hunting down planets, it's important to understand that black holes don't actively seek out objects to devour. They are not like predators in space, chasing after stars or planets. Instead, their immense gravity simply pulls in whatever happens to come too close. Despite the relatively safe distance between us and PBCJ 2339, the discovery is still extraordinary because it challenges what we thought we knew about black holes. How could a supermassive black hole suddenly change direction like that? What caused this unexpected shift? The scientific community is still grappling with these questions. Some researchers believe that the black hole may have collided with another galaxy, which could have triggered the rotation. Others suggest that internal dynamics within the black hole, such as the movement of gas or the rearrangement of mass, might be responsible for the sudden change. While we may not yet know the exact cause, the event has piqued the curiosity of astronomers, as it offers a glimpse into the complex and often unpredictable behavior of these cosmic giants. As if that wasn't mind-blowing enough, the transformation of PBCJ 2339 from a radio galaxy into a blazar adds another layer of intrigue. Radio galaxies are known for their strong emissions of radio waves, typically coming from the active nuclei at the center of galaxies, where a supermassive black hole resides. These galaxies are often characterized by the presence of powerful jets of radiation that extend far beyond the galactic boundaries. However, when PBCJ 2339 shifted its orientation, it became a blazar, a special type of radio galaxy where the jets are aimed directly at Earth. Blazars are incredibly fascinating objects. Their energetic emissions can produce intense bursts of radiation, sometimes flickering or varying in brightness, as they send radiation our way. The fact that a black hole can change its orientation in such a way that its jets are now pointed toward us is both an extraordinary and rare occurrence. While blazars can be exciting to observe, they do raise important questions about the potential risks of such events. The radiation emitted by a blazar is extremely powerful, and if one were closer to Earth, it could have significant effects on our planet's atmosphere, potentially leading to disruption of communications or even damage to satellites. However, the vast majority of blazars are located so far away that they pose no real threat to our planet. Even though their emissions can be bright and energetic, the chances of one of these phenomena causing harm to Earth are exceedingly slim. This discovery has opened up new avenues of research for astronomers, who are now more determined than ever to study black holes and their surrounding jets. These jets are thought to be crucial in the transfer of energy within the immediate vicinity of supermassive black holes, and they play an important role in shaping the surrounding galaxies. As charged particles are propelled into space at close to the speed of light, they interact with the gas and dust in the galaxy, releasing energy that can influence the behavior of stars and the formation of new celestial bodies. In fact, jets have been observed to extend far beyond the edges of galaxies, potentially affecting the larger cosmic environment. Thanks to advancements in space telescopes like the James Webb Space Telescope, JWST, scientists are now able to study these jets in real time. The JWST's incredibly sensitive instruments can analyze the composition of the particles in these jets, providing astronomers with detailed information about the gases, chemical elements, temperatures, and speeds involved. This data is invaluable in helping scientists better understand the dynamics of black holes and the role that jets play in the evolution of galaxies. With such precise measurements, researchers can make significant strides in unlocking the mysteries of the cosmos and deepening our understanding of black holes and their immense influence on the universe. The question of why black holes exist at the centers of galaxies is another topic that has intrigued astronomers for decades. We don't yet know for sure whether galaxies form around black holes or if black holes form as a result of the collapse of a galaxy's central region. What we do know is that black holes are a key element in the formation and evolution of galaxies. The presence of a supermassive black hole at the center of a galaxy exerts an immense gravitational pull on the stars and gas surrounding it, and this pull plays a significant role in the formation of the galaxy's spiral shape. It's almost as though black holes are both destroyers and creators, shaping the galaxies around them as they consume matter and release energy. The process of galaxy formation begins with large clouds of gas and dust that collapse under their own gravity. As the material in the center of this collapsing cloud condenses, it forms a supermassive black hole. This process is strikingly similar to the formation of stars. When a star forms, it begins with a cloud of gas and dust, which eventually collapses under its own gravity, forming a dense core. The same principles apply to black holes, though on a much larger scale. Once a black hole forms at the center of a galaxy, it begins to attract surrounding gas and matter, which gets pulled into the black hole's accretion disk. As the matter spirals into the black hole, it heats up and releases radiation, which can ionize the surrounding gas, contributing to the growth of the galaxy. While black holes themselves don't create galaxies from scratch, they are undoubtedly central to the dynamic processes that shape the structure and evolution of galaxies. The interaction between the black hole and its surrounding environment is a constant feedback loop, where the black hole's growth influences the galaxy's growth, and vice versa. This feedback mechanism is known as active galactic nucleus, AGN, feedback, and it plays a crucial role in determining the final size and structure of a galaxy. In some cases, the feedback from a black hole can trigger periods of intense star formation, while in other instances, it can limit the growth of the galaxy. The exact balance of these forces is still a topic of ongoing research, and it continues to challenge our understanding of how galaxies evolve over time. As fascinating as black holes are, they also present certain dangers, particularly if one were to wander too close to Earth. The closest known black hole to our planet is called V616 Monocerotis, and it's located about 3,000 light-years away. While this may seem close in cosmic terms, it's still far enough that there's no immediate threat to our planet. But there's always a catch: we don't yet know all the black holes in the universe. Some black holes may roam freely through the galaxy, moving from one region to another. These wandering black holes could pose a greater risk, but fortunately, astronomers believe that any wandering black hole would be easily detectable due to the gravitational effects it would have on nearby stars and matter. If one were to come close enough to our solar system, we would likely notice its presence long before it posed a danger. Of course, the most well-known black hole in our own galaxy is the supermassive black hole at the center of the Milky Way, known as Sagittarius A star. This black hole is about 26,000 light-years away from Earth, and while its gravitational influence is immense, it's not something we need to worry about. Sagittarius A* plays a key role in the dynamics of our galaxy, but because we're located far from its center, we're not in any immediate danger. The stars in the Milky Way, including our Sun, are all in orbit around Sagittarius A*, and this gravitational pull helps to maintain the overall stability of the galaxy. The possibility of a black hole coming closer to Earth is a hypothetical scenario, but one that astronomers have carefully considered. If a black hole were to drift closer to our solar system, the gravitational effects would be catastrophic. The tidal forces generated by a nearby black hole could disrupt the orbits of planets, possibly even pulling Earth out of its orbit and sending it spiraling toward the black hole. Fortunately, such a scenario is considered highly unlikely. The chances of a black hole wandering into our neighborhood are extremely small, and there's no evidence suggesting that one is on a collision course with Earth. In conclusion, while the idea of a black hole heading straight for Earth is certainly terrifying, it's also highly improbable. The discovery of PBCJ 2339 shift in direction has certainly captured the imagination of the scientific community, but it's important to remember that this black hole is located far away, and it poses no immediate threat to our planet. Black holes, with their immense gravitational forces and mysterious behaviors, continue to fascinate astronomers, and their role in the formation and evolution of galaxies is crucial to our understanding of the cosmos. However, the threat they pose to Earth is minimal, and with current technology, we would likely detect any wandering black holes long before they could reach us. So, while the universe is full of surprises, there's no need to lose sleep over the idea of a black hole heading toward our planet. The cosmos is vast, and for now, we're safe.